Hey, welcome to solving systems of equations using elimination. To use elimination means that we are trying to eliminate one of the variables to solve for the other variable in a coordinate pair so that when we graph the two lines, we see where they intersect. But I'm going to start today with two equations that have no variables. And I want you to point out that we know 6 plus 2 is 8 and 3 minus 2 is 1. This is true. So I'm starting here because I want you to recognize that we can combine these two equations as if they were a series of terms that we were adding up vertically, and we would get another true equation. So 6 plus 3, I'm just going to put parentheses around this equation to sort of separate it from the addition sign. 6 plus 3 is 9. Positive 2 minus 2 cancels out to be 0, so I'll just say plus 0, equals 8 plus 1 is 9. Now 9 plus 0 does equal 9. So interestingly enough, this is a true third equation that comes from adding the first two. So with elimination, we sort of want to do this exact same thing, and we can say that the positive 2 and the negative 2 in here, they eliminated each other. So we're going to try and do that now, but with variables x and y. Okay, so look at these two new equations that I wrote. 2x plus y equals 8, x minus y equals 1. I'm hoping you can recognize how this equation pair is similar to this equation system. Can you see that 2x relates to 6 because x is 3, so x twice will be 6. 2 times 3 is 6. And then the y's, I just chose 2 as positive y, so negative 2 is negative y. They're opposite each other. I said they'll still cancel each other out. And I still have 8 and 1, my constants, that will equal 9. So now I'm going to try and add these two equations together, even though now they are linear equations with two variables, the same way I did with this set of equations. So I'm going to again sort of separate it out with parentheses just to make sure I recognize I'm adding each term. So 2x plus x is 3x, plus y minus y cancels out. I could write plus 0, but I don't have to. Equals 8 plus 1 is still 9. Now at this point, this is an equation that I can solve for x. If 3 times x is 9, I could divide each term by 3 and recognize that x has to equal 3 because 3 times 3 is 9. Does that make sense? I hope so, because if I plug 3 back into the equation right here, 3 times 3 is 9. So now I recognize that my solution is a coordinate pair, so it has to be an xy value set. I have 3 for the x. Now I got to find y. How can I do that? Well, I can plug 3 into either equation, and when I pull out a y, it should be the same thing because it's where they intersect. Let's try plugging in x into each equation. So for the first equation, 2 times 3 plus y equals 8. So 6 plus y equals 8. I'm going to stop here and recognize that y has to be 2, or I could subtract 6 from both sides. Cancels out. Y equals 2. So I'm pretty sure that my answer is 3, 2, right? But let me just double check by plugging it in to the other equation as well. So the second equation, x minus y equals 1. If I know that x is 3, then I should really write 3 minus y equals 1. And at this point I know 3 minus 2 is 1, so I'm pretty confident that y equals 2. But algebraically, I subtract 3 from both sides, so I've got negative y equals negative 2. And if that's the case, If negative y equals negative 2, then I know the opposite of y must equal the opposite of negative 2, so positive y equals positive 2. So either equation I plug x back into, I get out the y value of 3. That means I have my solution to this system of linear equations, and I used elimination. Now, let's try it with another equation where each of the equations has been written in standard form. So this is a system because there's two equations, and I'm going to try and use elimination to get rid of one of the variables. My eye is drawn to the fact that I have a plus 3y and a minus 3y, and I know that 3y minus 3y equals 0. So to me, I'm going to add these two equations together vertically. Remember, I'll use parentheses to separate. 2x plus 6x is 8x. 3y minus 3y cancels out. And then 5 plus 3 is 8. Well, if 8x equals 8, then I know that 1x must equal 1. And I can show that by dividing through by 8. 8 eighths becomes 1, so 1x equals 1. Okay, so if that's true, now I need to plug those in and see if I can get a y value out to finish off my solution. Remember, my solution is a point on a graph where the two lines intersect. So I've got 1, and then I've got, we don't know yet. So let's try it. I'm going to plug in x into the top equation first. So I get 2 times 1 plus 3y equals 5. So I'm going to simplify. 2 plus 3y equals 5. Subtract 2 from both sides. That cancels out. 3y equals 5 minus 2 is 3. If 3y's is 3, then 1y must equal 1. And I can show that by dividing through both terms. 3/3 is 1, so 1y equals 1. So down here in my solution, I'm thinking the answer is going to be 1, 1. But I want to make sure that I'm totally true, totally right. So I'm going to plug in 1 back into this equation as well. 6 times 1 minus 3y equals 3. 6 times 1 is 6. Minus 3y equals 3. Subtract 6 from both sides. It's not a good looking 6. That cancels out. So negative 3y equals 3 minus 6 is negative 3. Now I can divide through by negative 3. And negative 3 over negative 3 is 1. So 1y equals negative 3 over negative 3 again is just 1. So I plugged in my x value of 1 into both existing equations, and I got the same y value of 1. That means I probably did a good job. I did it right. And I'm asking you to practice this so that you can do it right as well.